Hello all. My name is John Burke. I'm the CTO at Nemertes, and welcome to our webinar, Cutting the Cord, Going All Wireless All the Time, or Look Mom, No Cables. We'll start by discussing whether wired Ethernet is dead and then discussing why it probably is and where it won't be, and then some motivations for considering an all wireless future, including the savings you might get by going that way. We'll talk about what's coming up next and end with some recommendations. But first, a word from us, Nemertes. In case you're not familiar with us, we are a research firm that is focused on identifying the value that organizations get by deploying emerging technologies. So we're focused very much on the forward edge of the technology envelope and on identifying the success metrics that help folks determine whether they're getting the bang for the buck that they're looking for, and the cost analysis, benefit analysis, ROI type information that really helps nail that information down. So we first asked ourselves and asked an audience like yourselves the question, is wired Ethernet dead, back in August of 2015, and we've revisited the topic multiple times since then. At the time, the answer was no, not quite yet. Keep hooking your workstations up to wired connectivity, but we can see that the end is coming, because by then we could see that the next iteration of the Wi-Fi standard would probably do the job, would probably be the wired Ethernet replacement that everybody was looking for, or seemed to be looking for. That standard came out in 2019, and we have been in the end times for wired Ethernet ever since. And so, yes, the answer for this year, the answer going forward, as far as we're concerned, is yes. For most companies, for most spaces, and for most end users and devices, yes, wired Ethernet is or should be dead. So what happened in 2019 was that the next version of the Wi-Fi standard, 802.11ax, came out. It was also rebranded as Wi-Fi 6 by the Wi-Fi Alliance, which is the industry group that handles certifying cross-function among solutions and allowing vendors to put the Wi-Fi logo on their gear. They went with Wi-Fi 6 to try and make it more like the mobile world, where everybody could talk in shorthand about 4G, about 5G, whereas we in the wireless LAN space, we're still talking about 802.11a or B or G or AN. So they wanted to tighten things up, and it's actually made the conversations a lot easier. Wi-Fi 6 advanced previous standards significantly. With AC, we had been able to hit connectivity speeds theoretically around 1.2 gigabits per second, almost always in practice significantly lower than that. AX, Wi-Fi 6, pushed us well beyond the 1 gigabit per second mark, which was sort of informally the line we had to get across to really think of it as a replacement connectivity for wired Ethernet generically. And so with the release of that standard in 2019, there started a slow but massive transformation, and massive because of the enormous amount of installed plant out there. Slow because in order to fully take advantage of Wi-Fi 6, both the client and the access point have to be Wi-Fi 6 compliant. So in addition to upgrading all of that infrastructure built into the buildings, there had to be a generational swap of endpoint technology as well, which has been underway ever since. And also COVID-19 happened, and that took a lot of focus off upgrading infrastructures in office buildings in favor of upgrading the infrastructure required for remote work. And so there was kind of a slowdown in progress on this during the peak of the pandemic, but now as we're in the waning phase, or even past the end of it, we're starting to see activity and interest pick up again. The reason we're having this conversation right now, the reason we're answering the question, is Wi-Fi dead, is because we get asked by our clients on an ongoing basis, should we go with an all Wi-Fi standard in our offices? Somebody's pushing us to go all Wi-Fi, and we don't think we should. Well, here's the answer. The answer is yes. Here's why. So Wi-Fi 6 is making a difference for a lot of reasons, but primarily because it brings to the wireless LAN a broad array of technologies that are aimed at making it more useful in a broader variety of use cases. So making it better suited to be the primary network for just about everything in a given space, and not the optional best effort means of connectivity that it had often been in a lot of companies, or the thing that was only for guests, but everybody on staff was plugged in. Instead, it's aimed at making not just mobile devices happy, but also general end user computing devices, laptops, desktops, as well as multifunction devices and servers, things that are still out there in a lot of branch offices, and IoT gear of all types, whether it's the low and slow consumers of bandwidth like thermostats, or the real-time performance sensitive things that are out there like forklifts operating inside a warehouse, robotic forklifts, that is, or the kinds of things that generate massive amounts of data, where you might be talking about like a jet engine or something that's spewing out gigabytes or terabytes of information in the course of an hour. And Wi-Fi 6 is built to be applicable across all these kinds of use cases. That's because of a couple of key technology choices that it makes the default and fully integrates into operations. One being MU-MIMO, or multi-user, multiple input, multiple output construction. So it's got multiple antennas, and they can be focused on different client devices. So instead of basically time sharing a single broadcast environment where a slice would go to this client, then a slice to that client, and then a slice to the next client, and then back, it can have multiple simultaneous conversations with those separate clients. So that's made a big difference in terms of its ability to serve low latency and real-time type use cases, as well as its ability to support more devices in a smaller, in the same amount of space. Another key technological difference is the introduction of multi-user orthogonal frequency division multiple access. And that's quite a mouthful, but what it means is that the different bandwidth, the different pieces of the bandwidth spectrum that AX has access to, it can slice up into, I think it's 256 subcarriers per channel. And it's able to allocate bits of those channels. So some of those subcarriers to one client, and a bulk of them to another client, to combine subcarriers from multiple channels to a single client. And so to make it much more flexible in terms of how much capacity it's giving to each client device, and it's able to negotiate on the fly how much the device needs. So things that are low and slow get a very small slice. Things that are trying to throw a lot of data around very quickly, they get a lot of slice or multiple slices, and basically, again, promoting the ability to serve more devices and to serve a broader variety of types of devices with the kind of connectivity that they need. In addition to that, it reverses the trend visible in the previous iteration of the standard, which had taken the 2.4 gigahertz frequency frequency spectrum out of standard use and shifted to the higher end of the spectrum. AX puts, I don't know why gosh, the diagram says AX. It should say AX. 802.11ax puts those things back into service by default, which is great for devices operating at low power, which is great for devices operating over long distances, and which is great for spaces where there's more interference in the higher frequency spectrum. So again, pardon for that mistake on the diagram there. Oh, gosh, no, the diagram is perfectly correct. It says AN, and that's the older standards. It should be AC, and then the newer stuff on the right is Wi-Fi 6. So it should say 802.11ac on the left. My apologies. Correcting my correction. Okay, moving right along. The last thing that Wi-Fi 6 brings to the picture that was not there in the previous iteration of the standard is smarter collision detection on its carriers, so that it can spend more of its time in productive conversations as opposed to figuring out whether it's okay to have a productive conversation. So previously, if you were lucky, your Wi-Fi infrastructure would be able to run at 70% of its theoretical maximum capacity. And now with this smarter means of figuring out whether it's okay to talk, you'll be able to use more than 90% of its theoretical maximum capacity, all of which means, again, more use cases, more kinds of use cases can be served using the Wi-Fi 6 infrastructure. I'm going to take a moment here and say, if you have any questions, pop them into the questions panel in the interface for BrightTalk, and I'll do my best to answer them as we go. And of course, we'll have a little time at the end for answering questions that I haven't got to yet. Slide's not advancing. There we go. So combining all of these technological improvements, we can see that there are some significant cost-affecting improvements in play. If you look at the older standard, 802.11ac, you would see that you needed approximately one access point per 1,600 square feet, and that would be able to cover about 30 simultaneous client devices. With Wi-Fi 6, that number of devices per access point doubles, and the square footage that it covers almost doubles at the same time. So 60 or so clients across about 3,000 square feet of space. So you can cover more of the real estate inside your real estate with fewer access points. You can cover more client devices simultaneously per access point. So you can potentially reduce the number of access points in your infrastructure at the same time that you ramp up your ability to serve, ramp up the number of devices you can serve access to with good performance. And I think that this, as much as anything, is key to decommissioning wires to endpoints. And so we'll talk a little bit more about why that helps so much in a second. But it's probably good to point out that it's not all beer and Skittles. There are still some challenges with using Wi-Fi to replace wired connectivity completely, but now they're more specific to given situation than they are generic to the wireless technology. And when I say specific, I mean they're really related to the space that you're trying to put Wi-Fi into and the geometry of that space, whether or not access points can be easily within their coverage distance of the thing that needs connectivity. Whether or not, even if it's within the distance limitation, it's got a good clear line of sight, or is it around 2 corners or 3 corners? Are you trying to provide Wi-Fi signals in a space that is constructed in a way that makes Wi-Fi unhappy? Are you looking at modern drywall construction, which can be no problem at all? Are you looking at older plaster and lath construction, which might be okay depending on what the lath is. If it's wood lath, no problem. But if it's old chicken wire type lath, you could have serious problems. You're basically talking about a partial Faraday cage wrapping the room. Are you trying to provide Wi-Fi in places with big electrical or plumbing walls in between one of the users who's supposed to have access and the access points that are supposed to provide it? All of those things can make an enormous difference in how well Wi-Fi can deliver services without sticking an access point, directly above the user who's trying to reach it. It's also important to keep track of humans and their usage of the space. It's all well and good to take a big empty space and lay out a Wi-Fi mesh to cover it. But if you then fill that space with hundreds of humans, the radio characteristics of that space will change dramatically. Humans are, after all, roughly 5.5 feet of highly conductive fluid that walk around. And so they reshape how radio waves propagate in that space as they move. Consequently, in order to deal with these kinds of challenges, it's important that IT shops be ready to buy or lease or borrow surveying tools. There's plenty of free software out there if you want a handheld kind of device to walk around and do the surveying with. That's the kind of thing you can buy or rent. Getting those, you can both do the site mapping that lets you put your access points in the best places theoretically, and you can then also use them in troubleshooting as you try and resolve problems that maybe happen because suddenly they've doubled the number of people working in a space, or they've thrown up partition walls between all the cubicles, and the partition walls have a lot of plants on top of them. All sorts of things happen in real office spaces, any number of which can affect Wi-Fi reception. And so it's important to have the tool set you need to figure out how to resolve the problems once they've arisen and exactly what the problem is. We still also see, and it's increasingly rarely, use cases that require such high throughput with such low loss, or that are moving such enormous volumes of data that Wi-Fi still won't quite cut it, that you need a dedicated 10 gig link to the device, or maybe even fiber and running it above 10 gig. But as I say, those use cases are getting more narrow. They're becoming, very remote corner cases, and much less likely to arise in any kind of typical office scenario. And we used to see a lot of folks say that the security available in Wi-Fi was just not adequate to their needs. But with Wi-Fi 6, we don't think that's the case anymore, that it is more secure in itself than its predecessors have been. And that if it's coupled with zero trust network access, as it should be in any organization going forward, it can be as secured as wired for all practical purposes. You may feel differently if you're trying to run a secure, confidential, or classified document environment for the federal government or the Department of Defense. But again, those are corner cases, and for the vast majority of enterprise use cases, security should no longer be treated as a significant ongoing challenge to using Wi-Fi to replace wired. So thinking about motivations to make the change, people don't drop wired connectivity because they can. They drop wired connectivity to try and improve their environment or save themselves money. And I think the thing to start with, the underlying assumption to take into consideration, is that usage patterns and user demand are making it unavoidable to deploy ubiquitous, high-performing, and secure Wi-Fi. The longer you refrain from that, the more of an impediment to the business doing business you become. So start with the understanding that you're going to be putting Wi-Fi 6 out there. It's going to be everywhere, and everyone's going to want to be able to use it. Now, once you start with that assumption, then the question becomes, why am I keeping all of this end user wiring plant online at the same time? And the answer is, why? Why are you? The answer is you don't have to. So probably you shouldn't be. Once wired becomes something that uh, is going to be there in addition to a Wi-Fi network able to meet all the end user's needs, the decision to keep wired connectivity in place becomes easier. And the easier answer is, I probably don't need to. And so folks that we interview on this, folks that we talk to about this, they turn off their wired connectivity in favor of wireless connectivity. For the small handful of wired connections they still need to support, they terminate them into the same switches that the access points are plugged into. And they've just gotten rid of a whole layer of switching in their infrastructure, turning it off. They're no longer powering it or having to deal with the heat load it generates. So they're getting savings right away. That way, they're saving themselves on the capital side when they don't have to replace those devices, and maybe double saving if they can turn them into shelf spares for the switches that remain in service. They're also being able to buy fewer licenses for switching software and buy less maintenance and support service for switches. And so all of that can lead to significant savings, both on the capital and on the operational side. Some of the savings will also come from reduced spend on building out new spaces or remodeling existing spaces, because you no longer have to worry about repulling wired connections when all the cubicles move from the middle of the room out to the edge of the room. You no longer have to worry about pulling new wires in a space you move into fresh, and you don't have to think about upgrading aging cable plant if you've got some that's getting past its prime. You can even think about pulling copper out of the wall during remodeling projects. You can sometimes sell that stuff if it's in good shape to folks who need the wires, and you can sell it as scrap for copper if it's past its useful life. You're even going to be having fewer and less expensive wall jacks in place. And again, that contributes to the bottom line in your construction budgets, your remodeling budgets, and in your operating budget in IT. Fewer chances for things to get damaged and have to be replaced or repaired. So lots of potential for savings once you accept the fact that you're going to have a ubiquitous, high-performing Wi-Fi 6 network in place. And it's probably important at this point, when we talk about going cordless, we can talk about dropping your wired WAN connections too. Certainly, we've done a fair number of webinars. You can look back in the channel for wireless WAN related webinars, so I won't recapitulate everything that we've done on that here. I will simply point out that with 4G and even more so with 5G, wireless data services have become fully capable of serving as primary connectivity for a number of your WAN sites, especially if they tend towards the smaller. It's no problem at all to envision replacing T1s, multiple T1s, with wireless connectivity, higher bandwidth, more reliability, lower cost typically than a T1 at this point. If you're looking at 10 megabit wired connectivity, maybe a cable modem, a lot of folks we see, if they're not ready to go primary with wireless, will bring it in as backup connectivity, something that they can load balance across while everything's good, something they can shift their services to if the cable gets cut or the cable network goes down because of router problems or any number of other issues that can arise. So we certainly see a lot of folks easing their way into using wireless WAN as primary connectivity via the route of getting it as failover connectivity. It's also a great startup mode, using a wireless WAN connection to get a site up and running, bringing in wired connectivity if and when it becomes necessary. We saw in our most recent research on the subject that more than 3/4 of the enterprises we interviewed are using wireless WAN in at least one site. Wireless WAN only, their only means of communication with that site. We are seeing broader interest in bringing it in more sites, partly driven by the rise of SD-WAN, where it just becomes another kind of connectivity available at the site. And the spread of 5G is also driving broader adoption. We're even seeing folks drop the wireless LAN entirely, just throw out everything we just talked about Wi-Fi 6 and using just 5G services, both for site connectivity, maybe for devices in the site, multifunction type devices in the site, and for data services to end user devices, laptops, tablets, phones. So before we wrap it up with some recommendations, and I'll urge you again, if you've got questions, drop them into the Q&A tab, and I will get to them as best I can. Upcoming, we have as our next webinar, and it's in just over a week, want to improve your cybersecurity? War game. Great topic, should be a great session, and a lot of really solid and useful information on improving your incident response posture, your incident response policy. Recently, we did webinars on the 8 pillars of digital transformation, a great refresher course for folks who've maybe lost sight of what it really means amidst all of the marketing fluff that's been generated on top of it for the last 7 or 8 years, and mastering the metaverse, trying to peel away the layers of obfuscation that have accreted around that just in the last year or two, to really nail down what it will mean to operate in a metaverse, what it will mean to operate a metaverse. So some really great topics available in replay on our channel already. And for those of you who are IT professionals, which is to say not sales folks working for vendors, for those of you who are IT professionals, we'd like to invite you to apply to join our community. It is a place where IT folks talk to each other and to us. And we dig into lots of current events. We dig into lots of ongoing issues in the IT space, and generally provide both great brainstorming space and a sympathetic ear. Plus, we'll get all the jokes if you want to make some tech jokes. We're all nerds. So wrapping it up with some recommendations. If your sites are suitable, and there's still a few that aren't, go wireless LAN by default. So make your standard approach. Everything attaches wirelessly unless there's a specific reason not to. Require a use case justification for wired endpoints. So again, if the default is wireless, make people justify getting wired because of the extra expense. Find or buy mapping tools and consider managed services for managing your radio space. It's something that some folks don't want to spend their time on. So managed services is an option. And there are, as I say, lots of tools out there, free software, dedicated hardware, all sorts of things. With all of that in hand, and with sites transitioning to all wireless, reduce your wired plant to just what is needed to support the access points and those few remaining wired endpoints where somebody was able to make a business case for putting wires on it. Explore wireless WAN. If you're not comfortable using it as primary services, if you're not using it anywhere primary yet, plug it into your SD-WAN as additional connectivity and get used to it. See how you like it. See what kind of a pricing plan you can get from your provider. Evaluate it as an option for primary connectivity. Evaluate sites for 5G communications only, i.e. not even looking at Wi-Fi 6, but just at everything in that endpoint on cellular data. Experiment in a few places if you've got the option. And lastly, consider reselling the stuff you can strip out as no longer needed in order to offset some of the costs of upgrade. Um, You'll definitely have surplus switches. You'll definitely have surplus copper, which you may be able to access and remove. I mean, if it's just running in cable trays around the ceiling of the office space, and I was in a space just a couple weeks ago that was filled with it, you know, there were probably uh, half a ton of copper hanging around the edge of that room's ceiling. And it could all be pulled out because not a single one of those connections terminated at a workstation any longer. Um, and with that, and lacking questions, I will say thank you very much for your time today. My name is John Burke. I'm with Nemertes. Please join us again for our next webinar. Thank you.